My name is Jake, and I'm one of the senior geoscientists here at Ellipse. In today's video, I'll be covering a few ways to create geobodies within PaleoScan. Let's jump in. So the first way I'm going to show you guys to create geobodies actually requires going through the model grid process to create a geomodel and then extract a horizon stack. So it's this horizon stack data object that we need to use in order to create geobodies in the first method. Now, the other method I'm going to show you involves using the two-channel volume blending viewer in association with the Crossplot tool to create a class of geobodies that we can then use to constrain our geomodel or model grid on the front end. So two different techniques, two different purposes. Both are really accurate. Both are really fun. Let's show you just a little bit about how each of those work. So the first method I'll show you, which requires the use of a horizon stack, is very unique to the software. It's going to give you a very high level of detail depending on how densely populated your horizon stack is through your area of interest. Now, this is just one of the ways that we can create geobodies within the Geobody module itself. Like I said, I'm going to highlight the Geobody from horizon stack, but we can also create layers from horizons or from horizon stacks, and we can also create layers from geomodels. And so these are all considered geobodies. I'll only be highlighting this first method today just because it is really unique and it's actually really fun, a way to create very detailed, accurate geobodies. Now, the second way I'll show you today is probably my favorite way for creating large geobodies, especially those salt flood volumes that you have. If you want to create like a large salt geobody, this is a really great way. And in fact, the demo I'll be showing you today is just that. It does offer a very high level of detail, but like you'll see in the demo, it typically does require just a little bit of post-geobody creation editing. In this case, I'll be splitting and then merging this geobody in order to get just the geobody that I want to have to move forward to constrain my model grid. Now, I won't be going through the model grid constraint workflow here. That's part of another video that we'll be doing in the coming months. Today, we'll just be going through the geobody creation. So with that, I'll go ahead as soon as we go through the geobody creation. I'll show you a couple things that we can do with those geobodies. We'll display them in 3D. I'll show you how to quickly create isocores and our horizons from layers or geobodies. We can do some quick volumetric calculations, and if you wanted to export either the geobody volumetric table, we can do that, and I'll also show you how we can export those geobodies for use outside of the software. All right, let's jump right in. So I've got my PaleoScan project pulled up. And well, first thing I'll do is just open up a seismic inline so we can kind of find ourselves. And then the other thing I'll do is open up a horizon stack that I made previously. So you'll notice the yellow line is the intersection of the horizon stack and my seismic inline. One of the first things I'll do is tile these with a Shift H, and then I'm also going to turn on this auto contrast. This auto contrast option here is going to recalculate the max and min value for my horizon stack so that every time I cycle through my horizon stack, I'll get a very consistent color scheme. Now, I know that there's this really cool gas cap kind of further up here in this section, and you'll see it lighted up quite nicely here in my RMS. And so I can use my cross navigation tool to then bring my inline directly to this gas cap so I can kind of see what that looks like in an inline view, right? So if I zoom in here, you'll see here's this expression of this gas feature. So the first thing we'll do is kind of focus more on this gas cap. And the way that we do this for this method is we're going to interact with my color bar. So if I bring my cursor up to my color bar and I roll my scroll wheel, you'll see I'll be able to actually create a binary color scheme, right? So essentially what I've done is I've made the highest amplitude values and the lowest amplitude values very, very binary in essence, um, thus highlighting the feature that I'm hoping to build this geobody from. Now, the next thing I'm going to do is I'm going to grab this red triangle here, and this is a marker. So if I grab that and slide it across, you'll see I've colored in certain amplitude values, this blue color, right? So what I want to do is just slide that marker over so that my this expression of this gas cap here is going to be completely filled in. And the reason I want to do this is because the Polygon tool that I'm going to use is linked to this marker, right? So if I bring my cursor back up to my Geobody toolbar and I click on this Polygon creation tool, all I have to do is click once in the marked area and you'll see a small polygon pop up. Hopefully you guys can see that. You see the outline of that polygon. Now it's got a bit of a smoothing operator associated with it, so it's not going to be perfect, but it's very, very, very accurate, at least for this purpose. Now the next thing we're going to do is just jump to the next horizon slice and do the same thing. I'll click once to set the polygon, and I'm just going to step through my horizon slices, picking the expression of that 3D object for each slice. Now you'll notice I've come to a spot where I feel like maybe I could fill in a little bit more of that area. So I'll grab that triangle and I'll increase those values, and then I'll click once to set that polygon. Okay. So I feel like I've gone through all of the horizon slices that encompass this gas cap, and I've placed a polygon on each of them. And you'll see if I step back through, we'll be able to see all of those polygons that I picked. So to build a geobody, now what I'll do is come back to my geobody toolbar, and I'm going to click on the valid button. This valid button is going to bring up a dialog box, and it's going to ask me, what do I want to do next? Do I just want to display this geobody in 3D, which is fine, because if I decided I like it, I can select it and save it as a geobody. If I'm certain that I've done a good job, I can just say, no, I know I just want to save it, or I can do both and save and display. Now, a neat additional feature here is the ability to save the polygon objects. And so if you wanted to, you could turn this button on and it's going to save the polygons for each of the horizon slices that you picked. And you could use those later, perhaps if you got a reprocessing job on the seismic and you wanted to redo this process, and compare and contrast the difference between the two. Now, I'll just say display and say OK. The software then opens a 3D window and displays the 3D object that I built. So this is a nice little geobody of that gas cap based on the horizon intersection of my seismic. Now there's a few things we can do to this, and I'll cover those a little bit later, but the first of all, I'll show something really quick right now, and that's just how we change the color or the appearance of a geobody. Now, a geobody is a static object with regards to its shape, so I can't edit its shape, but I can change its appearance. And the way I do that is by selecting it, by double-clicking with the selection mouse mode. And you'll see if I look at my properties pane, I now have the ability to change the edge color. Now, the edge color is the only thing that I'll be able to see differently in 3D. In 2D, we'll be able to see the lithology fill and also the background and foreground color. I'll just change this to a nice green color. And you'll see I've changed the color of that geobody. Now, if I were to tile my windows with a Shift-T command, you'll see in my 2D window, I have the expression of that geobody. And if I wanted to select it and alter the lithology, let's say I want to make this, I don't have a gas, but let's say, I believe this is a chalk. Why not? I can change that to a chalk. I'll say OK. And now you can see the interior of that geobody has then been given that chalk litho identifier. Okay. Now I'll cover some of the volumetric and isochore work a little bit later, but for now I want to jump into the second method for creating geobodies, and that's using the two-channel volume blending viewer in association with the Crossplot tool. So I'll close all these windows with a Shift-C command. In fact, I'll remove everything from my 3D objects list because I want to start fresh. Okay, so for this technique, we're going to interact with the two-channel volume blending viewer. And that is found in the main toolbar here. There's a number of options, but for this, we're going to choose the very top one, and that's the two-channel volume blending viewer. Now, typically, I feel the most used application for this tool is blending volumes of different attributes together to try and have certain geologic or structural features pop out. But for this technique, we're going to do something a little different. I've got a really nice velocity model here that shows a great salt flood. And so what I'm going to do is I'm going to drag and drop that velocity model in the first channel. And instead of choosing something else, I'm going to actually cross-plot it with itself. Now, this is important because it allows us to be very accurate with the picking of our velocities. Now, I don't think grayscale is a very useful way of displaying velocities, so I'm going to go ahead and change that really quickly to the velocity 2. There we go. Okay, so what I'm doing is I'm blending the same volume with itself. If I wanted to, I could apply certain attributes, but that's really not necessary here. Really, what I want to do is use this to interact with my crossplot. So I'm going to collapse this initial window. And off to the right-hand side here, you'll see this button says Crossplot. If I click on that once, it's going to open a Crossplot window. Now it's blank, and I need to update that Crossplot. So I'll click on the Update Crossplot button, and we see this linear regression. Of course, it's volume cross-plotted against itself, so you expect it to be linear. And the idea here is what we want to do is tell the software to show us in this crossplot the salt velocities. So I'll go ahead and kind of zoom in here. I'll get nice and tight because what I got to do is I'm going to paint just a small area. So I'm going to work from left to right across this window, right? So I'm going to start with the Crossplot Creation tab. And the mode I think that works best for this is the paintbrush. So if I click on the paintbrush, I'm going to come in here and I'm just going to paint a smattering. I don't need to paint the entire body. I just need to select a few examples of the velocities that I would like to have included in my class selection. And now I'll simply say, show me on my crossplot where those values are. So I clicked on show and you see it turned most of them gray, but I've got these red dots indicating those are the places with the values that I've painted, right? So that's just a general region that I need to encompass to create a class, right? So this class is what's going to become my geobody. So if I move from left to right, now that I've shown myself where those values are, I need to somehow segregate those. So I'll click on the class selection button. And just like I did in the initial tab, I'm going to select a mode here. So I'll just select the ellipse. I could select a box, or I could create my own polyline, but an ellipse will be fine. And all I got to do is just put an ellipse around those values. And you'll see I picked a few things, but it didn't really get it. I think I must have missed that high value right there. That's okay. I have a way of editing that ellipse. So by changing the mode to that editing mode here, I'll double click on that ellipse. I'll grab this little green icon. I'm going to spin it around. And as soon as I let that go, it's going to update. And you'll see it's now included that salt body, right? Well, it looks like maybe I've got the majority of that salt body, but I feel like maybe I can get a little more accurate with the edge, right? So all I have to do is grab this little toggle here and pull down a little bit. And you'll see the more I move, the more it's going to update instantly. Now, so far, I've done a very good job of just picking the salt body, but at some point, your sediment velocities are going to approach your salt velocities. And if that happens, you'll see something that looks like this. See on the bottom of my image here, you'll see that that class now includes some sediment. Now, I don't want that. I can show you guys a few methods for creating an extraction area to exclude portions of sediment, in this example, from being included in the building of my geobody. So I'm going to skip over the auto classification and regressions tabs. That's something for a different day, and go straight to the outputs creation. So if I had a horizon, either above or below some of these salt features, I could drag and drop those here and create essentially an exclusion zone outside of those horizons where no geobody would be created. Similarly, with a horizon stack, I could just pick a upper and lower horizon to be the exclusion zones. But I could also constrain that with another geobody, or I could create a box, right? So this is just a custom box. And if I turned on this custom box here, you'll see that I now have these toggles around my blended window, and all I'd have to do is bring this up and say, okay, only create a geobody inside this box. Now, if I was just doing this on my day-to-day, this is probably what I would do. However, I want to use this opportunity to show you guys how we would separate out certain pieces of a geobody if I didn't realize they were included in the geobody creation. So just for this demo, I'm going to say I want to create this, even though I know it's going to include this sediment velocity, or the sediment portion down here, along with what I want to just be the salt body. I'll jump back to my class selection and just show you guys, if I don't like the color of that geobody, I can go ahead and pick my own color. Let's see, sure, this orange color looks nice. We'll make that orange. I can name this if I want to call this salt. I would come to the outputs creation, and I would say create geobodies. Now, for the purposes of this demo, I've gone ahead and done that already. But on your day-to-days, you'd say, go ahead and create this geobody, and when the process finished running, you would have something that looked a little like this. So here's that salt body with that sediment. Hopefully it looks pretty familiar. And essentially what I want to show you guys now is how we separate certain aspects of a geobody that is considered one whole geobody. And in this case, I'm going to get rid of this large blocky sediment layer down here. So what I'll do is I'm going to just double click on the geobody. It turns red, indicating it's the selected object. And then in my geobody toolbar, all I have to do is click on this split geobody /layer button. And when I do that, a new window is going to open, and it's going to have, so it's gone ahead and broken up all of those geobodies into individual components, right? So can you see what I'm saying here? It's if you look, that individual geobody previously was one geobody, and it was made up of these 30 some odd components. The splitting geobody tool allowed me to split them all apart. And then at the bottom of that tool, you'll see these sliders. This is a filter, so very similar to the fault size filter that we showed in the AFE video. We'll do the same thing for a geobody, and I know that large geobody is kind of the largest thing in here. So I'm going to grab this toggle and just move it over a little bit, and boom, there you see it's disappeared, right? So now that I've gotten rid of that, I'll say okay. And now, unfortunately, the software has gone through and it's created, 30 individual geobodies, right? But I want them to all be one geobody in order to be utilized in my model grid constraint process. Now, if you wanted to, you could just save one of these, by double clicking on it. For instance, if you were only working in this, eastern or southeastern corner of your survey, and you only needed this geobody, you could just save this out on its own. But for me, I want to put these all back together. So the easiest way to do that is to select a single geobody, and then just like you would select everything in a PowerPoint slide, you'll do a Control A, and that's going to select all of the geobodies in that 3D window. And then come back to the geobody toolbar, and right next to the splitting icon, you'll have the merge icon. So you just click on the merge icon, and boom, here we go. They're all back together as one geobody. Now there's one more step we have to do, and that is we need to save this as its own entity. So again, I'll just double click on it. I'll come to my Save Selected Objects button. I'll give that a name. I've already created this salt final. So you would say okay. I'm going to just cancel that because it might take a second, and I've already, of course, already done that. So I'm going to remove everything from the 3D objects list, and I'll just show you what the final salt might look like. So there we have it. So there's the final salt body that I created very quickly from a Crossplot tool, split it apart, and merge back the pieces to have that single GeoBody. Now, I would now use this GeoBody to as an input to constrain my model grid, for instance. So that's kind of one of the things that typically I would do with a large salt body. However, I want to show everyone some of the things that we can do just with GeoBodies. So for instance, I created a really nice layer from this clinoform section. I'll show you guys here in the seismic. So if you guys have noticed, there's this really nice clinoform section here, and I was able to create a layer based on a upper and lower bounding horizon that basically encompasses that entire clinoform section. And so one nice thing for clinoforms that shows up very nice is to create an isochord to see where the thickest portions of that clinoform section is. And so to do that, I'm going to click on the isochord icon in my general GeoBody toolbar. I'll tell the software to create the isochord for my clinoform. I have the option to snap this surface to the top or base of my GeoBody. I'll say the top. I'm going to use the seismic as the input. I'll say next. And just like we had with the original GeoBodies, I can either display or save and display, but I'm going to display this in 3D. I'll just say finish. And now we have a really quick clinoform built, a very quick isochord built from that clinoform section. I could save this as a structural horizon if I wanted to, and if I wanted to, I could also map attributes onto it. Now, another thing we can do with GeoBodies very quickly is to get volumetrics from them. If I want to just get a quick volumetric calculation, a gross rock calculation from this clinoform section, I can double click on it to select it. And then I'll go up to my Compute Volumetrics button. Clicking on that, because I'm working in time, there's a really quick conversion factor here. So you can make that whatever you feel is accurate. And then we have all the industry standard units to display. So in this case, I could say barrels, and you'll see that I'm now displaying a gross rock volume in barrels of this clinoform section. Now, if I wanted to maybe get more than just a single GeoBody volumetric, I can click on this Geobody Classification icon. All I do is drag and drop any GeoBodies that I want to get a volumetric or a surface classification from. If this works for GeoBodies, layers, and multi-Z objects. And you can see, just like the individual tool, there is a conversion factor. I can see the volume, this is gross rock volume, total surface, and projected surface of all of these. Again, just like the original, or the individual, I should say, it has all the standard industry units to display. I can export this as a CSV or as a .txt file if you want to bring that into another software. And also, I can then choose to export any of these by going to Export GeoBody. Now, GeoBodies can be exported in ASCII or GoCAD, whereas multi-Z objects, which we didn't cover today, but they are slightly different than just standard GeoBodies, are only a GeoCAD export. So you could export any of these for use in softwares outside of PaleoScan. Okay, that's the entirety of the demo I wanted to show you guys today. Again, as always, thanks so much for stopping by and checking out this video. I hope you learned something. If you have any questions on this video or any other of the modules or anything else you'd like to see within the software, please shoot us an email at support@ellipse.fr. We'll get back to you as soon as we can. Look forward to seeing you guys on the next videos. Take care. Have a great day. Bye-bye.